In the last section, we talked about graphing square root functions, and today we'll talk about graphing cube root functions. So a cube root function, f of x equals the cubed root of x, kind of looks like this swooping S shape here. And so we see that we've got 0, 0, because the cube root of 0 is 0. And then from there, going to the right, we've got 1, 1, because the cube root of 1 is 1. And then we've got 8, 2, because the cube root of 8 is 2. That is to say, 2 times 2 times 2 is 8. Going the other direction, we see that it follows some symmetry here with -1, -1, and then -8, -2, seeing as -2 times itself again gives you -8. And the standard form looks very, very familiar. It looks just like the square root functions, only instead of a little 2 here, we've got a little 3. Everything else is exactly the same. A is still going to be your vertical stretch or compression. K at the very end is going to be your vertical translation, so shifting up or down. Remember that these are intuitive. These kind of make sense to us. Whereas on the inside of the cube root here, we've got B and H. These are going to represent our horizontal stretch or compression and our horizontal translation or shift. Keeping in mind that anything that's horizontal is kind of the opposite of what we expect. And we saw a lot of that in the last section. So let's just start out with describing the transformations that are happening on the parent function. So I've got, for number 1, the cube root, and then on the inside, x plus 4. Now this plus 4 is going to tell us to shift left or right. And because it's inside, it's horizontal, it's the opposite of what I would think. So this is going to be shifting to the left 4. Next, we've got the cube root of x, and then -7 at the end. So -7, because it's at the end, it's vertical. Vertical kind of is more intuitive. We're going to shift down 7. For number 3, we've got a multiplier of 3 at the front. This is going to be a vertical stretch of 3. And then for number 4, we've got a 4 on the inside as a multiplier on x. Again, because this is on the inside, it's horizontal. This is the opposite of what I would expect. Instead of stretching by a factor of 4, this is going to be a horizontal compression of 1 over 4. Number 5, now I've got a couple of things happening at once. This is going to be a vertical stretch of 6. And I'm going to shift to the left 2. For number 6, I've got 3 transformations taking place. Let's start here. This is going to be, remember, the opposite. So this is going to be a horizontal stretch of 7 over 1, or just 7. I'm also going to shift to the right 2. And then up 1. Finally, number 7 here. Let's see, there's going to be a vertical stretch of 3. Shifting to the left 4. And then shifting down 8. And just like in the last section, we're going to be given problems where if I have the graph of this, I want to be able to find 2 points. One is the point of symmetry, and then I'm going to have a second point. I have formulas for this. The point of symmetry is at hk. That sounds familiar to us, just like square root functions started out, their initial point was at hk. My second point here, though, is going to be at h plus 1 over b, and then k plus a. So let's take a look here. I want to identify these 2 points to start out with. So on my graph, I'm going to have point of symmetry. This is always at hk. Okay, so what is my actual point here? My point of symmetry is this. So this looks like it's going by 2. So this is going to be 1 and then 7. So 1, 7. So this means that h equals 1, and then k equals 7. All right, next, my second point. This is at h plus 1 over b, and then k plus a. This point is actually at 2, 9. So now what I'm going to do is left equals left, right equals right. H plus 1 over b equals 2. And then I've also got k plus a equals 9. Okay, let's plug in what we have. H is 1. So this will be 1 plus 1 over b equals 2. Subtract 1 from both sides. One over b is equal to 1. So that means that b equals 1. Okay, over here, k equals 7. So let's plug that in. 7 plus a equals 9. We'll subtract 7 from both sides. This gives us a equals 2. And now that we have everything, we can put this all into standard form. So standard form is going back a times the cube root of b, and then inside x minus h, and then plus k at the end. So we've got a times the cube root of b, x minus h, and then plus k. Plugging it all in, I've got 2 times the cube root of 1, parentheses, x minus 1, and then plus 7 at the end.